Everyone, it's me, your Miss, and today we are going to learn elements, compounds, and mixtures, a very important in the first idea of chemistry. So let's start. First of all, we have some important terms that we must know about. The first one is matter. It has mass and occupies space. So next is pure substances, a substance that has a fixed composition and fixed chemical properties. These are all properties of a pure substance. Okay, suppose you can give the example as water, okay, or anything, gold, water, etc, etc. Okay, water or gold. Okay, these are all pure substances. Now pure substances can be, now see, pure substances are there only. Pure substances can be broken down into elements and compounds. So what is an element? Element, a substance that cannot be broken down into simpler substances. A substance that cannot be broken down into simpler substances. Means if we break a chemical, then we'll find that it has the same type of molecules. Okay, so it cannot be broken down into any kind of different atoms. Okay, by physical means also and chemicals means also. Now what is a mixture? A mixture is that consists two or more pure substances such as chemicals and compounds, and both retain their individual properties. Okay, both are retaining their own individual properties. So next is homogeneous mixture, a mixture in which the constituents are uniformly distributed throughout. Now mixtures are classified into two groups. One is homogeneous mixture, okay, and one is heterogeneous mixture. Okay, now what are these? These homogeneous mixtures are a mixture in which the constituents are uniformly distributed throughout. Now if you just look through the mixture, like if you just look through the mixture, you can't understand that it's a mixture. You will think that it's a compound, but actually it does not have the properties of a compound. It has the properties of a mixture. This is a homogeneous mixture. Now what's a heterogeneous mixture? Once you see, you will guess this is a mixture, this is not a compound. In one sight only you will guess it. That's a heterogeneous mixture. How can you guess? The constituents are distributed uniformly throughout. Uniformly distributed, you will think that they have formed compounds, but no, they have not. In this, it can be easily distinguished as it does not form the constituents non-uniformly. Okay, so this is what, okay, very nice things. Now what are the examples? Homogeneous mixture, salt solution, and heterogeneous mixture is mud water, okay, or sand water. Sugar solution also you can write in homogeneous. Suspension, a type of mixture. Now here you can see homogeneous and heterogeneous, one type of mixture. Now you will see another classification of mixture. Okay, mixtures are further classified into suspension, emulsion, okay, and colloids, etc. Let's see. Okay, we'll write down as we get. Okay, a mixture, a type of mixture in which the component is not dissolved completely into another component. Okay, now it is not dissolving completely, it is dissolving but to some extent. Okay, now these are two of the heterogeneous mixtures we have, suspension and emulsion. It's not completely dissolving, and another property which is very interesting is that all the solute particles fall down. Okay, the solid particles fall down. The solid particles fall down due to the force of gravity. The thing that we have next is next is emulsion. The type of mixture consisting. Wait, just a moment. So the type of mixture consisting of two or more immiscible liquids. Immiscible, they are not mixing also, so they are liquids. But in suspension you can have solid as well as you can have liquid. Okay, next one is alloy, the metallic mixture of a metal with another metal. It's a mixture, it's not a compound. Okay, Now, what are the methods of separation? We need separation to get the pure substances. Everything in nature is not a pure substance, right? You have to get the pure substances, right? So, there are methods of separation. What are they? Number 1, hand picking. Number 2, sieving. Number 3, winnowing. Magnetic separation, gravitation. Let's see, there are more, I think so. Okay? So, a method in which the components of a mixture can be separated by picking them with one's hand. Very tiring process. Okay? In the village they do, but very tiring process. So when man found that this is a very tiring process, we are getting tired, but still the mixture is not free. Then what did man do? Man thought of several principles that would make separation easy. Okay? The method in which the components of the mixtures are separated using a sieve. Now what's the principle working over here? The larger particles will stay above the sieve and the granular particles or the smaller particles will fall down. Okay, this is the principle. Winnowing. What happens? The method of separating the components by using wind or moving air. What is the principle? Principle is that the lighter particles will move away and from a separate row, and the heavier particles a separate row. Okay. Magnetic separation. The process is used to separate the mixtures when one of the components having made of use of iron. Now, if magnet is brought to a huge dump of garbage, there will be many iron coming out from there. Okay, pure iron coming out from there, because iron, nickel and cobalt, iron, nickel and cobalt will come are magnetic substances, so they will be attracted. Okay. Gravitation. The process is used for separating a mixture when one of the components of a mixture is much heavier than water and the another component of mixture is, let me see, much lighter than water. Now both the mixtures are mixed into, suppose this is a beaker and I take water over here. Now then I take oil also over there. Okay, so let me take water over here. Again I take so I take oil also, I mix oil, I pour oil over here, and then again I pour sugar particles over there. Okay, sugar particle. So what will happen? Now what is the change over here? See the change very clearly. In the next part, what you will see, that the sugars have gone down and the oil is up. Okay. Solvent extraction, a process used to separate the components of a mixture based on their relative solubility. Now what will happen if you mix two mixtures uniformly, then you will see that you get some mixtures are soluble and some are not. Okay, everything is not soluble in everything, right? Okay, so everything will not soluble. The one which is soluble will be soluble, and then the another mixture will be separated. And how can we get that mixture? We'll just evaporate. Okay, we got done. This is a very important process, fractional crystallization. A process used to separate components of mixture when the solubility of a solid component varies in the same solvent. So the solubility, there are different amounts of solubility. Some are sparingly soluble, some are insoluble, some are very much soluble. So like this you have. The one which is very much soluble will solute very fast, then you will separate it, right? Another which is sparingly soluble will do it in medium speed, you will separate it, right? Then again what happened? Another thing you will get which is insoluble, you will separate it. Okay, done. Next, sedimentation. The process is used to separate insoluble solids suspended in a liquid by allowing them to settle down. What happens? You mix mud and water, mud settle down, then you decant the clear water, you pour it without disturbing the sediment particles, you pour it to another beaker. Okay. Next, sediments. The solid particles that settle down to in the process of sedimentation. Now mud is a sediment, supernatant the clear liquid above, which we filter during decantation. Okay. Decantation, the process of pouring the clear water without disturbing the sediments. So without disturbing the sediments, we pour the clear water. Next, filtration, the process. Next, filtration, the process by which insoluble solid particles can be separated from a liquid by allowing the mixture to pass through a filter. The solid particles get stuck over the filter paper and the clear liquid passes down. Okay, finished. Pure water is taken. Okay, evaporation, the process by which the liquid changes into vapor state either by heating it or exposing it to air. This is a huge disadvantage that the liquid over here gets evaporated. Okay, and the solid is left behind and there you separate. Okay, crystallization, a process by which separating a solid and that has been dissolved in liquid is made into the solution. Suppose you take a super saturated solution and then you crystal it. Okay, you put it in the fridge and then you crystal it. Crystals will form. Okay, then you get the crystals. Okay, crystallization is this. Next, flotation. The separation technique is based on the principle of wetting of compounds of a mixture. Okay, this I need a diagram to show you. Sublimation, a process by which substances change directly from the solid state to the liquid state without passing to the intermediate liquid state. Okay, now it is very useful for iodine to get pure iodine. Okay, what happens in a conical flux, the any sublimate is heated and then what happens, it turns into vapor and there is cooling filters over in the top and then it gets deposited in the cooler parts of the conical flask. Now distillation, let me show. The process of separating a liquid into a soluble component by selective evaporation. Okay, now what will happen when now see, there is a solid and a liquid. You heat the liquid, it gets evaporated and then you have the condenser over there which again cools it down into the liquid and the solid is left behind in the round bottom flask and you get the liquid in the conical flask. Okay, distillation flask, a special round bottom flask used to perform distillation. Okay, you have another flask also over here but that's separate, used for collecting the water and etc. the liquid part. That's a conical flask. Centrifugation, the process of separating finely suspended solids components in a liquid by spinning the mixture in a closed container. When you spin the mixture in a very high speed, you will get it forms different layers and then you separate. Okay, centrifuge, a machine in which the spinning of mixture occurs. We cannot do it by hand. Okay, it has to take place in a machine. Okay, now separating funnel, the laboratory equipment made up of glass with a tap called stopcock. Now it's used to it is of the principle of heavier liquid and lighter liquid. The heavier liquid, now these are of immiscible liquids. Okay, the heavier liquid goes down while the lighter liquid goes up. You open the stopcock, you take down the heavier liquid. Okay, and then again you put back the stopcock. Again you take another beaker, you again put on the stopcock, and then you again take the lighter liquid. Okay, extractional distillation, the process of separating a mixture into the components or fractions by heating the mixture. This is in the principality of miscible liquids and it's of the boiling point. Principle of boiling point is used over here. Different liquids have different boiling points. So what happens when the boiling point which is of lower will get evaporated faster and then you will have a beaker over there. It will condense and again you will get that liquid. Okay, again another will heat up. Again it will go down to the condenser, put another beaker, you get another liquid, like this way. Okay, chromatography, the process of separating different components of a mixture by passing it through a medium in which the components move at different rates. Components absorption, the property of absorption in different rates. Okay, suppose red ink and blue ink. Red ink is absorbing faster, okay, and it gets deposited to the top of the paper, chromatography paper, and blue ink slower, so it gets absorbed in the bottom of the paper. Okay, you can have other objects also, but that you will learn in higher classes. Next we go to terms to know. At a glance. See, matter is anything that is occupies mass and occupies space. Matter are classified into pure substances and mixtures. Pure substances further elements and compounds. Pure substance has a definite composition, I have already told you, has definite melting and boiling points. Mixture has no different components, has no different melting and boiling points. The constituents of mixture can be separated by physical methods. Okay. So a mixture has no physical or chemical properties. There is no energy absorbed or released during the forma. Okay, these 2 points, mix it up and write. This is only over there. Okay. Now infographics, look over here. See, fractional distillation, see, I'll explain to you. Here you have the mixture of alcohol and water, okay? Any alcohol, ethyl, methyl, anything, okay? You heat and then you see over here the fractionating column, okay? It goes up over here, and then the one which is having a lower boiling point will go up, and then here you have the condenser, and it comes down to the condenser, condenses, and you have the water, okay? Then you have the alcohol which again is heated up, okay, over here, and then it again goes down. Place another beaker, you get the alcohol, okay? Next, paper chromatography. See over here. See, you see color spots over here. It is based on the property of absorption. Okay. Now what happens is a mobile phase and this is a stationary phase. Mobile phase means not your mobile. Stationary means not a stationary shop. Mobile means movable. Stationary means static. Okay. And see over here you have different dyes over here. And then what happens? You just put a paper over here. The paper absorbs different and now different things are having different absorbability. The paper is slowly lowered down, and then you have then the red ink first gets over here, and then the blue ink you get. Okay. Gravitation. See, if the sawdust flowing due to the action of gravity, it is settling down, and then you decant it, just like sedimentation. Winnowing. Just see, you have chaff and wheat. Chaff is the like the body skin of the wheat. Okay, so what do you get? You get lighter forms a heap over the right side because you are blowing the wind over here, and heavier gets stacked towards the down. Okay, heavier will not move towards that side because the wind cannot move them too much. Okay, so the wheat is over here and the chaff gets stacked over here. Separating miscible liquids. What happens? I told you. You pour down. Now see, you keep the mixture over here. Take the rest for some time. They will form separate layers. Open the stopcock. Water will fall down. Put another beaker. The oil will again fall down. Okay. Sublimation. You heat iodine crystal and iodine. Okay, mixture of iodine and sand. Sand will remain over here while iodine will sublimate. Iodine will form in the cooler parts of the conical flask. Iodine will form. Okay, so you get to both of them. Separation of ore from ganj. Okay, now see, heavy ganj, you have many gravels over here, and then what happens? The light now you let flow water over there, and then the lighter particles go up, and then you have them. Okay, or you can use the air also. Filter paper. Now see, now you don't have to learn all these things. These are not important. Just learn this type of diagrams. Okay, what happens? You just pour the sand and solution mixture over here. The sand will remain over here, which is the residue. Okay, and the filtrate, which is the pure water, will go over here. Don't need to learn all this. This is just for craft work. No need to learn all this. Hand picking, I told you. Evaporation. See, you heat the mixture of water and salt. Salt remains, water evaporates. Okay, in this type you get only one. Distillation. You see over here now. Here you have you put the fire over here, and then the water slowly rises. It condenses, Okay, you have water in, water out, passing cool and hot water. Thermometer is over here, and then you have the conical flask, okay, which collects the pure water. And here you get the sand or salt, whatever you keep. Sieving is you don't get the picture over there. Sorry, I can't show you. Okay, centrifugation. See, blood sample. Mix it in a very high, rotate it very high in a very high speed, and then you get different layers, and then you can decant. Magnetic separation, just you know that. Okay, thank you so much. Goodbye.